Hello, everyone, and welcome to the third iteration of the C# Learn Live. Today, we'll be talking about adding logic to our C# applications. My name is Filip Ekberg. I'm a Pluralsight author, and I'm here with my good friend.
Hi, I'm Iris Classon, Microsoft MVP, and I work at Blade.
Very nice to be here with you, Iris. Thank you for coming to my office and doing this here. We're going to have some really fun topics to discuss today. We'll be talking about adding logic to our C# applications. We'll be starting with some fundamentals around how to evaluate Boolean expressions and how to work with ifs and elses, and then we'll jump into some more interesting topics that will help you build your applications in your day-to-day job eventually.
Yep.
So how about we jump into VS Code and we'll have a bit of a look at what we're going to talk about today.
Yep.
So our first topic for the day, I'll be sharing my keyboard and mouse here, and we'll be trying to jump back and forth.
Yeah, we're not doing like pair programming. We're doing like programmer. We'll be switching.
Yes, we will. And you can comment on my my ability to type on this.
Is it CSI Miami who did pair programming with two people on the same keyboard?
Yeah, we should try that. I'll type on this half, and you can type on the other half.
All right.
That'll
as long
be a
as
lot
I
of
get
fun.
copy and paste, I'm happy.
Sure, we can figure that out. All right. So the first thing we're going to be talking about is how to evaluate a Boolean expression to make decisions in C#.
True.
This is one of the, I reckon, most important things to understand and how to apply in your applications.
Yeah.
Because otherwise, you won't be able to make any useful applications at all unless you understand this. So it all really boils down to being able to figure out if something is equal to something else or if it's not equal to something else. So to evaluate if something is true or not, we have to understand what equality is in C#. So a good example of that is, let's say that I want to compare the character A to the character of B. We know that they're not equal. Now, if you're coming from math, it's a little bit tricky to understand what's happening here. This here is creating an expression that will eventually evaluate to being true or not. If you're from the math industry, you would know that equals is how you compare if something is true or not. But that's not really the case in C#. So in C#, to evaluate if an expression is true or false, we use the double equals, which is the equality operator. We can also say that if they're not equal, which we know is true or false in this case, right? So now
for C#, right?
For
Let's not get into JavaScript.
Let's not. You'll eventually be able to be writing something like this right now. All joking aside, I've been doing a lot of JavaScript as well.
It's not that bad.
It's not that bad. It's pretty amazing. I love all programming languages equally.
Yeah.
So now that I know
Equally,
yeah, sure.
Equally.
Yeah. I love all of them. I just love programming. I use the right tool for the right job. But most of the time it's C#. So with that being said, I know that this here is an expression that will eventually evaluate to being true or false. And we'll be spending all our time in VS Code to experiment with these different things. But this here alone doesn't really make up for a good program. So most of the time you have data coming in from somewhere, like it could be input from a keyboard, it could be input from the web. So let's fake this. Let's say that I have my first variable. We should know now how to declare a variable. This here is a string, or we can use var, which will be short for that, right? I can do second is equal to b. I could also do first name, last name, or whatever you want to use as an example. Now, to compare these two and to make a decision on where to go next, I'd like to compare these two variables. And to do that, I need to introduce something called an if statement, or an if-else or else statement. These will help us make a decision in our applications to know what type of code to run next. So I can now say, well, if first is equal to second, I want to run some code, which is quite neat, right? I could say that, well, how about we want to write something to the console? So we can say A is equal to B, which we know is not really the case. Should be, is not equal to B, to be honest. And then now I've been able to say if these two are in fact equal, depending on the input to these two variables, I can make a decision on where to go next. So now I know that I have this expression. This here is an expression. I know that both ends has to be equal because I'm using this equality operator. I'm using it together with this keyword or this thing called an if statement. Now the input to an if statement is an expression, or rather, What it actually wants is a way for me to figure out if it's true or false.
Can you add to that? Or do you just have to keep it just to comparison of two items?
That's a very good question. So I could eventually end up having something that would say first has to be equal second. But we also have to have another expression to be evaluated to true, which could then be, let's say, we could say first is not equal to third. So I'd have to introduce a third variable to that, just to make this example a little bit
Do the
more.
whole alphabet.
Do the whole alphabet. We're only going to be talking about from A to Z.
I actually do not know if there is limitation to how big of a statement you can have.
Oh,
Because you probably don't want to try to figure out, right? Because you don't want it to get too long.
Yeah. No, you don't. You want to keep your code kind of short and neat to be able to maintain it. Eventually, when you build this in your real-world applications, it has to be readable and maintainable.
Yeah.
So that's a very good question. We can, for certain, we can add more statements to this here to make a more complex decision. We could also say that either the first is equal to second, or the first is not equal to third. But if we keep it a little bit more simple, we could say that first has to be equal to second, or we use the or operator to say that either first is equal to second or is equal to third.
So in which order does it evaluate the expressions inside it?
So in this case, it will evaluate the first one. If that's false, it will go ahead and evaluate the second one.
Yeah, and as soon as it gets a true,
it will go into that if statement and run the
unless
code.
we use an and.
Unless we use an and. Because if we use the and operator, it would have to evaluate this to true as well as the next one to be true.
Yeah.
So what we can also do here, I'm talking about true and false quite a lot. So in fact, the input to this if statement here that kind of looks like a method call, which is not, but it looks like one, we could think of this as being an input where we have to pass something that evaluates to true or false. So I could, in fact, take this portion here. Let's simplify this a little bit and say var result. And this here will now be a Boolean. So the result of the expression first is equal to second is what I can have as an input to my if statement, which is quite nice. So now I can make a decision on where to go next.
I was going to say it's more readable, but then again, we're using some very vague variable names.
Very vague variable names.
If result.
Sure, we should probably think about how to make this a little bit more.
You're going to try harder, Filip.
Sure, it would be much better to just name the variables A, B, and C, right? That's a much better approach, isn't it? We're going to undo that. So the input to an if statement is a Boolean expression, or what's evaluated to either true or false. And we know that this here could potentially be true. We don't really know yet. Like, we can look at the code and know that this is going to be false. But I guess the idea is that you don't know that when you run the application. That's why you want to be able to either run this if statement here if that yields true.
Yeah. As a matter of fact, if you type in if true.
Yeah, sure. Yeah, we can do that. So I can say if true, which is always going to be true.
And a lot of editors will actually tell you that this will always evaluate to true.
Yes.
You'll get a warning.
Yes. So if you have an expression that, as you're saying, will always be true, sometimes VS Code, Visual Studio, and Writer will know that. For some reason, it's not complaining about it here, but we can obviously see that this.
Yeah, we were playing around with the settings like 5 minutes before we started live streaming, so I don't know.
Probably a very good idea, isn't it?
Yeah, blame it on us. Yeah.
Yes. So now that I have this if statement here, like, I've made a decision, or let's actually revert this back. So now if the result is something, we know that it has to be true. Sometimes you might also say if it's actually equal to true. This here is ambiguous because you don't have to do the equals true here because these are exactly the same thing. But I reckon this is a little bit more readable. In some cases. I guess that's up for discussion. All right, so let's do if result. And now, if I want to expand this and make it a little bit more realistic, maybe I don't only want to run this code block if this happened to be true. Let's do this. I'm going to remove this just to keep the code a little bit more simple. So if first is equal to second, I'm going to do this code here. Do first I'm going to clean this up a bit so that everyone understands what's going on. So now, if first is equal to second, I'm just going to write that out to the console. And right now, if we run the application, it won't actually print anything to the console unless we change that variable. So we can see here that there's no output from the console. If I were to change these to be the same value and rerun the application, obviously, we'd get a output. First is equal to second, which is great. But what happens if this is, in fact, they're not equal, and I want to handle that case as well?
If or else?
We could add another if. So the interesting thing here is that if we do, if first is not equal to second, if we do this, it would always run the expression or evaluate this expression as well.
Yeah.
So what happens is if we look at the application from top to bottom, like this here, what's going to happen is that first it will evaluate if this expression values to true and then run the code inside that if statement if that's the case. And then it will run this block as well.
Yeah.
But what I very much...
It's a bit unnecessary.
It's a bit unnecessary. So it will always try to always evaluate this one here. But I only want to do this if this happened to be false.
Yeah.
Right?
If we
And the
want
way
to
that
add options, right?
Exactly. So think of it either first is equal to true or first is not equal to second, which we know that either this is true and then this is going to happen. But maybe we'd like to say if first is equal to third, just to keep it a little bit more complex. That's where we introduce an else in front of the if. But the else if always has to be coupled together with the if block or if statement.
And it runs top to bottom.
Correct. So now it will first evaluate if this expression is true. Then it will try to evaluate if this is true. And if neither of these are true, I might want to run some code as well. That's where we use the lonely the lonely else.
Yeah.
So if else fails, we're going to run this code snippet here.
It's like the backup plan.
It's like a backup plan, yeah, for sure. It's quite common to write code like this. Yeah. So you first check something that you're looking for, and then you might have some other cases. And then at the bottom, you might run some code as well. There's many ways to write this type of code, but this here is very common. And it's a way for us to make a decision on where to go next. Like we could have a method call here to run something if this is the case, or maybe it's branching off to some other type.
And you can nest like several if statements inside each other, like a little Russian doll.
Yes. There's actually an interesting challenge with that. If you find that you have a very long, what happens is that you might have code that end up looking like this. I'm just going to write if true here now. If you end up having code that looks like this, it's an interesting, it's like a beautiful arrow,
Christmas tree.
Isn't it? Yeah, isn't it?
Sorry.
Christmas tree arrow? I don't know.
My Christmas tree light. It's an arrow. It's an arrow.
Yeah, I'll invite you over for Christmas, and I'll show you how we arrange our tree here. It's
You're standing up.
Yeah, what? Sure. Yeah. So actually, if we find ourselves writing code like this, we could challenge ourselves to think around how would we refactor or restructure the code so that we don't end up having this layer of nesting. That's a little bit outside of the scope of this learning module.
But you can do this.
You can do this.
I think somebody said like you can drive a car with your feet, but that doesn't mean you should. So
how? I don't know how that would work, but sure. Yeah, so you can end up writing code like that, and it's totally fine. Like especially when you're beginning C# in your journey to learn programming. With that being said, we've covered how to evaluate the expression. This here constructs an expression that could yield true or false. We could negate this to say that, well, I'm not looking for a first is equal to second, and this here is the not equals operator. So you have equality and non-equality or inequality. And then what you also have is a way for you to say, if we go back to, if we have if true, you can always negate this to say that I want to run this statement if true is false.
Yeah.
Now, this is very confusing.
Yeah, it is.
But it might make a little bit more sense if we were to say var equal is equal to first is equal to second. if we do this, if they are not equal. Does that
Mm.
make more sense?
Yeah, that's easier to read.
Yeah. Yes, especially since not true wouldn't really work, but you get the idea, right? So you have many different options, and you can always negate these if these true or false Boolean expressions. And we're not limited to doing equality and or inequality. We can also use this with less than or greater than, which you might also know if you've done math.
The crocodile.
The crocodile, sure. So let's add that. Let's go down to the bottom, and I'm gonna do, let's say, int amount. I've purchased something for 300 kroners, and I want to check if this is above or below a certain amount to know if I should get a discount or not. So what I can do now is that I can say, well, if my amount is greater than a certain value, I could say if it's more than 300, you're getting a discount. And we could actually do int discount is equal to 0, and then we'll do discount is equal to 10%. So now I've said that if this thing here, this variable, is greater than this literal, so I've added the number 300 here.
So no discount, huh?
That's a pretty good discount, isn't it? Yeah, 10%.
Yeah, but there's no discount there.
No, I haven't added any discount yet. Sure, I haven't computed
Yeah, no, but
that
the
yet.
amount is 300.
Sure.
It's not greater than 300.
Right. I see what you're saying. So
Yeah.
now we wouldn't be getting. That's a very good question.
Discount.
So which of these two would now execute? You just said the answer to this.
Yes.
Actually, we're not getting a discount, and that's because this here is greater than. If we'd like to say if the amount is 300 exactly, I have a solution. I can say above 301. Is that a good enough solution for you?
Yeah, no, then no.
No? Okay, all right. Let's try something else. How about greater or equals?
Yes.
That's better?
Now I get my discount.
Right. So now we have the crocodile mouth and then the equal sign to say that if the amount is more than or exactly equal to 300, you're getting a discount. Otherwise, you're not getting a discount at all.
Mm.
We could also say, to make this a little bit more interesting, if the amount is greater than or equal to 200, you'll be getting a 5% discount. So we know that if the first one is not true, we know that it's probably below 300, right? So then it goes ahead and tries to evaluate this expression to ensure if it's more than 200 or not. If you haven't purchased a lot, like you're not getting a discount, right? I'm probably somewhere always over here, but spend way too much money on fun things. So now we've experimented with how to use the evaluate Boolean expressions. We've seen the if, else, if, and the else blocks and how they would work and how we can use these together with equality, inequality, the greater than, less than, greater than, and equals. And there's one more thing that I like to look at, and that's the conditional operator. So I could, in fact, write portions of this. Is it?
Yeah,
all right.
it
We'll
is.
get to this.
When I was young and it was introduced.
I think this was introduced a very long time ago. Sorry, I'm not saying you're old.
I am
Sorry.
old.
Well, I am too, so that's
He's
fine.
got like this beauty filter on.
Yeah.
We actually look like hundreds, but yeah.
Yeah. And
yeah.
Oh well. So before I actually show you the conditional operator, there's one more thing I want to show you. These curly braces, they're actually not required. But we're going to get a little bit more into that later on, right? But I just want to show you that they are optional.
Is this out of scope?
It's probably out of scope for my thing.
That was a joke. Scope.
Funny. We'll get to that soon.
We'll get to the scope soon,
Yeah, we'll
and
get
I
to the
will
scope.
explain my
Yes.
awesome mom jokes.
All right, I'm looking forward to that. So now with this here, I've simplified this a little bit by making it a little bit harder to read, in my opinion. But we can have a discussion about that in just a moment. But what this leads to is that I'd like to somehow write a one-liner that says the same thing that I've done here. What I can do is use a conditional operator. So I could say amount is equal to, how about if the, sorry, discount should be equal to, if the amount is more than or equal to 300, I want to evaluate this to say that, well, if that's the case, then I can add a question mark to say that then you'll get a 10% discount. Otherwise, you get nothing. And now I've introduced a conditional operator, which is really nice.
An expression that evaluates to true or false, question mark, option 1, option 2.
Exactly. And we could always take this one step further and also include the second one, because we know that if amount is more than or equal to 300, we're going to get 10%. But if that's not the case, we're always going to run this portion of the code here, which is essentially this here. So I could actually take this portion and say that, well, if the amount is more than or equal to 200, you'll get 5% discount. Otherwise, you get nothing. And we can clean this up a little bit to make it a little bit more readable.
I'm not sure that helps.
Sorry, I'm sorry.
It looks like Greek.
So my job is normally to write as confusing code as possible to keep myself employed.
There are other languages for that.
Yeah.
I mean,
certainly.
yeah, you can.
It shows you though how expensive this is, how much you can do with this.
Yeah.
There's kind of no limits to how unreadable your code can be, right? But we can undo the last part and just show you exactly how the conditional operator works. That would at least take care of that first portion of the code. All right, so I think we covered all of the portions in the evaluate the Boolean expression to make a decision in C#. Because now I've made a decision to give you a discount based on a Boolean expression. This here evaluates to true or false. We've experimented with if and else and if else. And I think it's to not get out of scope, it's your turn to talk about scopes.
Ooh, it's my
I tried to make a joke.
It's my time to shine.
Yeah, go for it.
Yeah, I said the joke first.
Yeah, that's fine.
I'm actually really, wait.
Do you want to swap keywords?
No, I just want to see if it's the same language. It is.
Yeah.
What? I have my own keyboard, but it's a clicky one.
It's very clicky.
That's very clicky.
That's fine.
That's how I make sure everybody hears I'm working. All right. I'm going to be cheating and look at the notes. I'm not as well prepared as you, Philip.
Ah, well. Just scroll down.
Let's see. Scroll.
There we go.
All right. I'm going to delete all your stuff.
Oh, that's fine.
Are you sure?
Yeah,
like
that's totally fine.
Where did the mouse go? There we go. We have like 5 screens here.
Way too many.
I don't know where to look.
I'm going to move over this a little bit. There we go.
All right. So I'm going to be talking about variable scope, or we're going to talk about scope, which is actually really interesting. I have a lot of fun stories about that. Fun for me, not so fun for people who went through it. So as Philip showed you, like if you do an if, I'm just going to add true here just to keep it simple. What you have here, these 2 little squiggly brackets, those 2 mossfinger, like birds, bird wings. We call them in Swedish, bird wings.
Such a weird.
I call them code hugs. This is
nice.
Scope, and in C# you define scope by using these brackets. And all right, I'm just going. I regret actually deleting your stuff because now I could have used it. If let's just name, we'll do the name because we did that last time. Where did that come from?
I don't know.
I didn't even type that.
I have a second keyboard where I'm typing things.
I don't do that, Philip. Don't do that. All right.
I'm just kidding.
If name equals, I'm not going to do that. Okay, do iris. All right.
Right.
We're evaluating an expression, and if it evaluates to true, it's going to run the code inside this scope. So let's do, I'll show you an example here. I'll just do a console write line. Here we go. It's like whenever you type on somebody else's keyboard, it feels a bit strange.
And we have the identical keyboard.
Not completely identical. I'll show you the difference afterwards. I'm just going to go ahead and just do this. String interpolations. Interpolation.
It's an amazing feature.
Interpolation. Sorry. My name is okay. I'll do this one as well. No, I'll just here. This doesn't make any sense, so just ignore this example. All right. Anyways,
It makes sense. We could think of the name being something that comes in from the console or somewhere else, right?
Right. We'll do this instead.
Nice.
Okay. My name is the same as. No suggestion? No? There we go. All right. It is complaining. Its value never used. I'm actually using the value okay. so stuff is salting me. And the lonely else. I like how you just you call it the backup plan.
The backup.
All right. So now it's going to compare the two names as Filip explained earlier, and it's going to output the above. We have here, we actually have two scopes here. So if I were to declare a variable inside here, and I'm just going to grab the output here. I'm usually quiet when I write, so that's why I was like, I'm not saying anything. I cannot multitask like you do. And here I'm going to go ahead and wait, no suggestion? What is happening here? Why won't it let me do this, Filip?
That's a very good question. So can you explain what's happening here? I can clearly see that output is in between your brackets over there, but why can't I access that here?
He doesn't know, so I have to tell him.
I have no clue.
Yeah, it's just like, how do you even keep your job? Okay, he's a consultant, that's why. So I cannot use this variable because I've declared it inside a different scope. So it's not accessible from outside. It's not accessible here. It won't be accessible in there. It's only accessible in here within these brackets. However, if I were to declare the variable first up here, just to set it to an empty string, you can even do string.empty if you want
Probably
to.
a good idea.
So.
And they have different names. So just you forgot a T in the output.
Oh, that's why it actually let me write that. See, now it's going to complain because I'm trying to declare the variable again. So I have to remove the var, so I'm not declaring it. I'm assigning instead. Now, when I do this, I'm actually allowed to do this. And if I run the console app, it's going to output. So that is the easy explanation of what a scope is. A scope is the part where. That's where when you declare something inside the scope, only children from that scope is going to be able to access the variables on the outer scope, but not the other way around, and not from one scope to the other.
So if you were, can you try and comment out line 3 here? Like remove the output that you have up on the top here. And could you add output in both the if and the else block, the same variable in both of them? Would that work?
Var.
Yeah.
Var. Copy paste. Let's try and see what happens. Oh, yep.
Interesting. So even though we have them both in all the available scopes, because we said that else is basically what's like the last resort and all we're going to run.
Yeah. But it's a different. It's a different scope.
Okay.
And there was actually a famous bug by a company which shall not be named, but has the logo of a fruit with maybe a missing bite. I don't know. I'm just making stuff up.
Not prepared.
That actually did have a really big security bug. And let's say if var important security stuff, run this. Okay, I'm just going to set this to true. And it looked something like this. Important security stuff, run this. And then it I'll just doing important security stuff. So the original code looked like this.
Mhm.
But as Philip explained, we are allowed to do this, right?
Mm.
This will output because it's always set to true, right? But what happens?
So in what scope is that living in now?
So it's in an invisible scope. The compiler does all the magic for us. So
Right.
the brackets actually do exist. We just do not see them. And some people don't want to see them. However, it's very easy to introduce a bug here like that. Maybe some company with maybe some fruit logo did, where they wanted to add more important like security stuff.
Mm. Right.
And then they added another line. But the thing is that the security stuff 1 and 2 was only supposed to run if the condition was true. And you can find the code online for this if I wasn't completely making this up.
We could actually try this, right?
Yeah.
So set this to false. And then run the application. I want to see what the output is here. I have no idea. Actually, I do, but I'm kidding. All right. Wow.
It did. It did the important security stuff too, and it wasn't there. It's scope, is it? No, can we not use white space to scope things?
So if there's someone on the stream watching that's done Python, this here would in fact, these 2 lines would be the same scope.
Yeah, and also, what are you doing here? Just kidding. I love Python. So.
It's a great language. I love it as well.
But it's very, very different.
It's very different, yeah. So in Python, you would define a scope with using a tab, right? Like this here. But in C# it doesn't work like that.
No.
So can you explain what's happening here?
Yeah. So what actually happens here is, I don't know how the shortcut for moving lines in VS Code. This is how the code actually looks like, even though we omitted the brackets.
Right.
So it will evaluate this expression, and if true, it's going to run this. But this part, it will always run because it doesn't have any condition. It's just there. It's always going to run. So stuff like this happens a lot, and that's why, like, although some people are fine with using one-liners, it can mess with scope, and also how easy it is to sort of misidentify the scope. Or However, I have to say, one thing I'm generally happy about doing is if you're inside the method and you want to return early, I'm more than happy to do a one-liner with a return, because that's, I mean, you're just doing a return. But
I have seen that quite a lot. And I've also seen that people think that they don't see this return because either they're like me and have really large font sizes, so the return is actually hidden outside of the
if
screen.
you have a very long expression.
Yeah.
So if you want to get into good habits, I'd still say just embrace the code hugs.
Yeah, always
or the
use
bird
wings.
The bird wings. I don't know what it's called. Måsvinge. I don't know what the moss is.
It's
like that,
the annoying birds.
The white annoying bird that likes to be by the sea.
Yeah.
Seagull wings, which makes it sound way worse than it is.
Yeah. There's actually an interesting thing here now, right? So you did an early return here. You have the return keyword, but you still have the curly brackets or the seagull wings.
Yeah.
And so you actually created a separate scope for that console write line, but it doesn't really belong to anything.
No.
Interesting. So you can do that as well.
Yeah. Sort of pointless, though.
It's quite pointless. Sure. Could you show how you would use a variable that you declare inside the if, and then also can you access that in an inside if? You talked earlier about being able to use them in.
Let's see.
Let's just undo all of it. Right. So could you now access output inside? If you undo that again, add the comment. If you add an internal if here, like one more, could you access output in a nested scope?
Yes. So it can access what's outside of its scope as long as it's sort of in a direct line out. So not siblings or nieces on some item. Somebody's going to tell me off my really bad German. But you can access parents and that way up, but not siblings or nieces,
Right.
as I said.
Okay.
So if
true,
if
that's
true,
could access
output
output, right.
equals, and I can set it to something else,
Sure.
and then I mean, if we had this,
It would make sense, right? It would be the same as we had earlier. I'm just curious what happens when you declare it, inside
so
scope.
if I declare the variable outside,
Mhm.
and I can access it inside if,
Right.
in a nested if, and then I can actually access it afterwards as well.
Okay.
All right, let's see. I just gotta make sure that I'm not missing something, because I just talked.
Yeah, so the scopes are actually very important. While Iris is just looking at that, the scopes are really important to understand, and they can cause really annoying bugs, especially if you don't keep into consideration that if you do like one-liners, just be careful.
I think I've covered everything, actually.
Yeah, I think so too.
That was fast.
Scopes are important, but
it's an easy concept to grasp. Until it gets nested and complicated. And in some languages, such as JavaScript, scopes are a bit more challenging, or used to be. A lot has changed. So, but we'll stick to C#.
Yeah,
just keep in mind that if you're interested in other languages, other rules might apply.
That's
just a
that's very true, though. Yeah, sure. So depending on what you like to program, like. Obviously, we're doing C# here, and there's some C# specifics, but most of what we've actually talked about so far is applicable in most programming languages.
Yeah.
Evaluating expressions, and there's always going to be scopes, and might differ how you define the scopes, but it's
all languages
it's
have
the, same, right?
the concept of expressions, Boolean expressions, evaluating, controlling code flow with conditions, variable scope.
Yeah. So with that being said, we're going to be talking about we're going to be branching the flow.
Yeah, because you kept adding ifs.
I kept adding ifs.
You kept adding options, and if you keep adding options, there might be a better option.
There might be a better option. Wow. Oh, wow. Okay.
My kids love me.
Wow. Okay.
I'm sitting closest to the door, so he won't be able to get out when I make my jokes.
Oh, wow. All right. Oh, wow. Okay.
At least I'm laughing.
That's fine. Okay. So, scoot over. Over here.
Oh.
There we go. So they can see both of us while we are typing in VS Code. The next thing we're going to be talking about is introducing another concept. So I don't have to add more ifs, but if I show you exactly what I mean here. So we can do if name is equal to Philip. I could say I want to run some code, else if its name is equal to Iris, else if not that. See, now we are running into my autocomplete that always messes with my head.
We had that problem last night. It comes up with the weirdest weirdest suggestions.
I can even type. All right. So if I want to add more things here, like the code is going to get a little bit harder to maintain and read, I reckon.
Yeah.
So instead of doing this, there has to be a better way to be introducing branches. Now, there is actually a way to do this, and there's a thing called a switch, a switch statement to be exact. This acts very much like the if. It works the way like we've just learned with scopes. It takes an input. Actually, the autocomplete here was really good. We introduce a switch, and we input something that it needs to switch on. So in comparison to evaluating an expression, what's happening in here is that think of this as an input to a method. It's not a method, but it's an input to the switch statement. So I could say, based on my name, I want to do something based on what this is.
Yeah.
I could then be adding some code here to say what's going to happen. So if I get rid of this final part here for a second, and we'll get back to that soon, I could be saying, well, if the case being that this is equals to Philip, this here will now perform a Boolean expression, or it will evaluate this to true or false, right? So based on the name, if that is equal to Philip, I'm going to run some code. I could say console.writeLine.
Dad jokes.
Dad jokes.
Yeah,
sure.
You do dad jokes. I do mom jokes.
Sure. So now that I've done this,
we have our own children. We're not.
it's complaining. Shouldn't be complaining. All right. Did I forget how to actually write a switch?
Yeah.
Probably.
Copy paste is your friend.
See, I just use AI nowadays.
So when I started learning programming, which is
Mhm.
10 years ago, I actually remember watching your sessions.
Oh, really?
Yeah,
Wow.
yeah, I do. I remember our teacher told us to never use a switch or break. Those were evil.
Okay.
But now they're quite in fashion.
They are.
Or, I mean,
Yeah, for sure.
it's been around forever.
Yeah.
But there was a lot of misuse with switches, where people instead of writing beautiful logical code with good flow, they would just revert to switches and just break.
Yeah. Yeah. So
yeah.
the thing I reckon that people don't like with the switch is that it can clutter the code a little bit.
Yeah.
There's a lot more noise in the code, and generally, if we look at C# and how that has evolved over the past 5 years, it's about writing less code. And there are ways to use the switch to write less code, but that's very much outside of scope and a little bit further on ahead in the path of learning C#.
Yeah, I quite like switches now.
Yeah, I like switch expressions,
Oh,
which are really nice.
yes.
Yeah, that's.
But we're not getting into.
I'm not. I can't show that. Oh well. Anyways,
We can't show you the cool stuff. Somebody else gets to do it.
yeah, exactly. So let's just pull apart exactly what's happening here. So I've introduced this switch statement that takes an input where, based on my name, it's going to evaluate if the case is that this is Philip. If that's the case, it's going to run the code that I have here. This here can be multi-line because this here is in fact a scope. Very much like if I had curly brackets like this here or my seagull wings. That would be the same thing, but no one writes code like that. We always just do this. And then it's followed by a break here to indicate that this case is now done.
Case closed.
We thought about the same thing. That's so funny. All right. Case closed. Oh, wow. Damn it. I need to be faster next time. All right. The case being this is Iris. We can run some code. Let's say console write line. And let's not do dad jokes this time. Let's do mom jokes.
Yes.
All right. And then I'm gonna show you another cool thing here. Like we could also say, for everything else, everything that's not Philip or Iris, I want to run some other code, like in our if, else if, or else block.
Funny jokes.
Funny jokes, exactly.
Yeah.
So I could say for everything else, we're gonna be running some non-funny jokes, right? And this also needs to be followed by a break. Otherwise, it gets a little bit upset. So with this being said, this here allows us to then add more cases to this to expand on the code, to add more evaluations based on if this is true or not. Very much like we saw with if else.
Yeah.
But this here is a little bit more tidier because now we have this expression or this block that is entirely tied to the input that we give it, and then we can run some.
It's tidier when you have more cases, when you have more options.
Yeah, for sure. Yeah.
Because when you had just one, that was.
Yes.
I've never seen that. Don't do that.
Yeah, and a side note here as well, like I do say case closed here, right, or break. I have that after all cases are done. But that's in fact optional. If I do this,
there we go.
I could say that if the case is Philip or if it's Iris, we're going to run some jokes. And my shortcut for removing one thing doesn't work, but we can do that, right? Just to make it a little bit more funny. So the switch statement is really powerful. It allows us to write code like this here to add more cases that we want to match on and expand on the code without having to introduce if else and so forth. And it's not entirely tied to being a string here. Like this could also be a number, right? It could be whatever. We could, in fact, also be looking at what type of object it is. We could be looking at a range of numbers. We could be looking at property values and so forth. So this is very powerful. It's one of those things that, as you mentioned, has become a lot more powerful and popular over the years. And with that being said, we've introduced this switch statement that takes the input. It has a few cases, run some code. We always have to add the break. If we don't, it's just going to continue running the next one. I think the C# compiler is a little bit smarter. I do remember when I started programming, you were able to do this in other programming languages, and it would just continue running the switch. But you're not allowed to do that in C#. So let's not even talk about that. But that could be a little bit confusing. This here is quite obvious that for both of these cases, it's going to run that portion of the code.
Yeah, and I'll tell you a secret. So it's not a secret if you live stream it, but I can never for the life of me remember how to write a switch statement.
Really?
Yeah,
Okay.
I always just write SW tab.
Right.
And then that poof, it just
Okay.
appears.
Yeah.
Because I don't use them that often. Like when I use them, they're like, I'm glad I can use this. But I actually have to not look it up because I'll just get the editor to write it for me. But yeah, I admit it.
And I think that's one thing that comes with experience with your favorite developer environment. Like you learn all these shortcuts and keystrokes to help you build better solutions.
Yeah, and you're not supposed to memorize like all of this. Like some parts, like have to do an if statement. That's pretty good to know.
Sure.
But when you're getting into a bit more complex things, it's actually completely fine if you have to look it up.
Yeah, for sure. I look up things all the time. Like it's
and you're a pro.
I'm a pro. Well, I do tend to tell. I don't tell my clients this, but I tell other developers that I'm just really good at using Google and now Bing and other AI tools, and use Copilot, use ChatGPT, and use that to help you build software. Like it shouldn't be a problem just being able to Google things. So.
Switch.
With that being said,
that's the only thing you need to remember. Switch,
exactly.
And that's what it does.
That's what I did, right? So I did switch, and then it just tells me I wanted to create a switch statement, and just tab, and it tells you how to build it. And that's the same for all of the different, I think, built-in things in C# and .NET. So it's not more complex than that, really. It adds the same type of functionality as the if. It's just an alternative way of expressing yourself and allows you to expand with more cases.
Yeah.
And write sometimes a little bit more readable code. But again, I do want to mention that don't write too much code in each case.
No.
Maybe branch out to a method call if you want to do that, just to keep your code a little bit cleaner. All right, so with that being said, it's your turn to talk about something very interesting. Now we're getting into some of the cooler stuff.
For so it's just really funny. I'm going to talk about a for loop. Right, you've already covered. They've already gone through for each, right? I believe so. Yes. So we're going to talk about for, which is also it's another way to iterate through a collection, or an array is on a collection. It's just a bit funny because for in Swedish means sheep. And I remember a friend of mine sent me a drawing of sheep holding hands. And he said, "Oh, look, it's a for loop."
So, okay.
So yeah, that's a dad joke. Sorry, bad.
My neighbors have sheep. I woke up one morning. Yeah, or four. Yeah, we woke up one morning and they were in our garden.
Oh,
yeah, that's.
Oh, I wouldn't like that.
Side note. So how about you show us what a for loop is and how it's different from a for each? Oh no! do you know how to write a for loop? I should go down one. Right, there we go. That's fine. We're all pros here.
I'm out. Goodbye.
All right.
Good night.
There we go. This looks a bit different than a for each loop.
Yes. So for each has already been covered, and in a for each loop or for each iteration, you go through each for each item. That's why it's called the for each. However, with for, it gives you other options. So it gives you more fine-grained control what you want to do in an iteration. Names.
And now you're creating an array of names, are you?
Yes. Filip. Just do everything in lowercase. Iris. Trying to come up with some other name. Louis. Yeah. That was one of the first ones to log in.
Yeah.
It is still there. Yeah. Shout out.
You can open the comment section and look who's there and just use all the names.
Oh, there's a lot of people. Renan, Wisdom Whispers. There we go.
Yeah, perfect.
Louis. Yeah, there we go.
Yeah,
Louis is there. Yeah,
Hello, Louis.
Hello. Okay,
Yeah.
there's some
And
weird names.
Banter Fam is talking about AI taking over. I think that's true. All right, so let's
Yeah,
get back
yeah.
to the for loop. Can you tell me, like, you now created an array of names here, right?
Yep.
Yep.
So now if I want to iterate through names dot length, if I want to iterate through the names, I could do this.
All right, you're gonna use an async local variable change args.
That close, but no, but
All
no
right.
cookie.
All right.
And this is how you access items in an array.
All right. Okay.
All
This
right.
looks very different from a for each loop.
Yes, it does. So this is just for an example. So I'm just gonna remove this one here. All right, now I have the name. I'm going to go right line, and I'm going to output the name. What do you think is gonna happen?
Hopefully, it's gonna write all our names to the console. There we go. Oh, that's nice.
Right. So
right.
basically, I've done what the sort of for each does, but for each, it's a bit more readable. Can you access the item directly? So what's the point of using a for loop? So in a for loop, you declare the sort of the iterating variable. This is the one that you're going to increase or decrease. And although it says ++ here, which is how you increment, you can change this. So I could do +2 and skip every second item, or I can do a reverse loop. So you do have a lot of options how you iterate through the items. Because say for some reason you have more complex collection and you only want to go through every second item, you can't really do that with a for each. Then you have to prepare the collection beforehand, and that's going to probably take some performance and some brain power as well. But with a for loop, you have the ability to sort of have more fine-grained control. Another difference is as well in a for each loop. This is C#. You cannot change the item you're currently iterating over. In a for loop, I still have access to the array here. So I can go ahead and, for example, set the name to something new. I'm just going to new name, and then I'm going to go ahead and output the there, and then I'm going to grab the name again. Actually, well, the name is there. I could actually just write a second loop and just iterate through it and output it.
Sure.
So what I'm set on now, when I'm doing this, I'm actually changing all the names to new name, and then also the number iteration it's going through. So you can change the items in the collection inside.
Could you also add to it? Could you also add names?
Yes.
Well, that's a static list, so probably can't, right? But if we play with the thought that it's an...
Yes, I can.
list.
So I can change the array to a list. Just go. A list is in C# a fancy array, a super duper fancy array. Under the hood, a list does consist of an array, actually. List of strings, and then I'm going to go ahead and add Philip, Iris, Louis.
Right, so now there's no length property anymore. We have to do count.
Yeah,
that's
count.
Fine. Okay.
So for each name, and I'm going to output just the count. here.
Sure.
Oh, wait, what am I doing? I'm just
That's fine,
typing
you're
away.
just-
I'm not even looking at the screen because I'm so confused with this keyboard. The reason why is because it switches the place of these two. Like,
All
yeah,
right,
yeah, on
okay.
mine plus is upper,
All
not
right,
lower. So
okay.
that's why I'm getting confused with,
Huh.
yeah, uppercase.
Interesting. Okay. Do names. Oh, maybe you can actually do names. Names or names.count. Like, doesn't matter, I guess.
Oh, yeah, names dot count. All right, so.
Let's run this. I have no idea what this is going to do, actually. I think we're gonna get a Stack Overflow.
Wait for it, wait for it.
So it's actually not going to finish, I think.
I'm just waiting for the overflow.
All right, yeah, we can wait. I only have, I think, 64 gigs of RAM.
Oh shit! Okay.
So we're gonna sit here forever. Like, sorry, you can run. Let's kill the application. So what happened here?
Yes. So I wanted to show like some of the, not the downsides, but some of the things you should be aware of in a for loop. You can go ahead and add to the collection. However, as you keep adding to the collection, you're increasing the collection, and it does evaluate the count over and over again for each iteration.
Okay.
So if you keep adding, it's going to keep looping, and you're going to keep adding, and it's going to keep looping, and it's going to continue and continue and continue and continue until you get a Stack Overflow. It's like a child asking for something.
Yeah, an annoying kid.
Yeah, again until you get a Stack Overflow or a mom overflow.
So they're actually not evaluated at the same time. The first int I, when is that set, and when does it actually do the evaluation of the expression?
So what do you mean?
Like, in which order does it run these different portions? So you're saying that it doesn't run, it doesn't complete because it keeps increasing.
Yeah.
Does that mean this evaluates every iteration then?
Yes.
That's good to know. I would probably have run into this more than once.
So let's see. Make sure that I don't skip anything important here.
So if we want to fix this code snippet here, could we add another, inside the for loop, we could add, for example, an if statement to check if the name is Philip, and if only Philip, we'll add a new person. Could we do that and see how that would work?
Yeah. If, all right.
And we have to access the current name, right?
That's so annoying in this. Names dot
element
at.
So that's a little bit different. That's another way.
It's very rarely I do this.
Yeah.
And that's why I had to think a little bit. If name equals Philip, I will actually add the brackets here.
Person. Right. New Philip?
No, sorry. Another Philip.
Perfect.
Now it's not going to run forever and ever.
Right. So what will this do? Let's run it and see what happens.
So we have 3 items at the start. And now we have 4.
4. Perfect. So it actually added that.
Yeah.
That's pretty cool.
I'm actually disappointed you have so much RAM. I was hoping it would just crash and burn.
Yeah. Wow. All right. Stream is over. Like, my computer is now crashed.
No, that wouldn't happen though. No.
Can we
the editor would crash, but not.
I want to test one more thing. Like, can we put a breakpoint on the if here and just I want to see run this with the debugger attached. I want to see if we actually get the name for the last one. So now name is Philip. We skip over that to the next one. Now name is Iris. Now name is Louis. So we're inside here and actually running this. So you are, in fact, very much correct, right? You were pointing to this earlier, that you said that it will evaluate names.count every time.
Yeah.
And we can access that element, which is quite cool. This is very powerful. This is one of the reasons I like using a for loop over a for each, for example, even though for each is a lot more convenient.
Yeah. And if you, Philip is going to talk, or we're going to talk about other ways of iterating as well. So if you want to do a continuous iteration until a specific condition is met, a for loop might not be the best way to do this. Now, how do I end this?
Who knows? I think over here.
Oh, there
Here
we go.
we go.
There we go.
There's,
I don't use this editor at work. I would
Yeah, me
have
neither.
loved. I would love to, but it was already pre-selected which editor we use. So,
Right.
all right. We have covered the basics of a loop. Maybe we
There's an
should
annoying
do.
fly in here.
Yeah, I know
Like, I'm
this.
gonna kill it. We're not just randomly waving. There's an annoying fly. So I live on the countryside of Sweden. There's
Let's
horses
see.
outside my door and flies everywhere. Anyways,
All right. Yeah, I guess we should show that you can. Did I show this that you could skip? So as with the if statement, you can also skip the brackets. However, then you can't do more than like run one line, because if you do that, it's going to
Right.
run outside of it. So I could do a console dot write line and go ahead and just type something like that.
in this case, I would prefer a for each loop, to be honest.
Yeah. Sort of pointless, but you can omit the brackets.
Yeah.
Doesn't mean you should, but you can.
You can. Totally fine.
All right. Then I'm not sure what else to cover here. I guess I could show I talked about skipping items. Int I, where's the example? I plus 2, no, wait,
It could be
no.
I++ here, and then we could skip over
yeah,
one in the loop, I guess.
I wasn't sure where I was going with this example. You can set I here as well. So if I set I to 3 in this loop, what's going to happen?
Oh, well, in this case, it's...
Will it ever going to get here?
Nope. I'm not sure. Let's try it.
So this is a typical programmer interview question, is where you have to do like a verbal debugging. So whenever you wonder what's going to happen, you could just run the debugger, but you could also walk through it. So I'm declaring the number of iterations, that's I iteration, is set to 0. Okay. And as long as the number of iterations is less than the number of items inside this list, I want to run this, and then afterwards I want it to increase it by 1. But the first time I run it, I set it to 3. So this part won't run again. It runs it only once.
Yep.
Then it's going to evaluate this, and 3 is not less than the number of items. It's actually equal to the number of items. So if I do this, it's actually really fun to play around with a loop statement, and I highly recommend that you do. All right, and I'm just adding the indentation, not necessary, but good for readability.
It's necessary.
So I'm going to run this. What's going to happen now? It's actually going to output this once, but only once, because as Filip talked about, this means less or equal to. So the first time it runs it, it's set to 0, but then I set it to 3. Although it's actually, first it's 2, then it's 1, and then it goes here and it's set to 3. Actually, I'm going to do this for readability. So better than my Swinglish.
First time it will be 0, though, right?
First time it will be 0.
Yeah.
First time it will be 0.
Yeah.
Let's just run this. So it will increase it after it has run this, but only if this evaluates.
And if you change it to 2 now, will it run this twice? Can we try that?
So it will output it the first time.
All right, perfect.
And then it will output it again and
Hmm.
and again and again and again and again, because we have never added a condition to actually break the loop.
Yes.
It will continue in all, not eternity, until we run out of
Until we end the stream, basically.
yeah.
Yeah. Okay.
No, there we end it. There. Oh no.
Perfect.
This was what I was hoping the first time
sorry.
it would happen, but now
Yeah.
I'm not actually able to
Alright.
kill it.
Oh, I keep waiting.
No.
Don't close it. Don't. Let me.
If I do keep waiting.
No, you'll be fine. You'll be fine. It's just a little bit annoying. You just have to be very quick. Pressing stop here, and it will tell the debugger to disconnect. Is it actually gonna break now? Do we kill the application?
Yeah, kill application and start a new one.
Oh wow! All right, let's do that. Let's see if we can do actually not open my Explorer. That's not really what I want to do. Let's try and open a new code window. Oh, what? You broke it.
No.
Actually, it was my fault. To be honest, right?
No, but I was going to show.
Yeah, no,
that's what I was trying to do
fine.
the first time, but yeah.
So you actually tried to. Let's look at that. No. All right. Fortunately for us, we can just reopen this, right? And I'm gonna kill the code. Let's not do that. Let's not do that again.
I'm too scared to see
Yeah.
what they've written to us. Like, what are you guys doing?
So let's not do these again. Yeah, let's actually open the chat and see if someone's screaming at us.
All right.
Probably not. So
all right, but
we're not going to run this again, but
no.
you said that we can break out of this.
Yes. So you don't want to end up.
Let's not accidentally run this again. Here we go. Sorry.
Oh, okay. All right. So when you want to break out of a for loop for whatever reason, you can break.
Perfect.
You can just break out of it.
Yeah.
And it's the same. It's the same break as you use in a switch, and that's how you terminate the iteration. If I have a code below,
right,
it's going to run that code. It's just going to terminate the loop, not all of it. I don't know if you've gone. If you people watching have gone through the whole writing a method or a function and doing a return. This is not the same as doing a return. A return will exit out of the method, while a break is just going to break the loop.
Did you know that if you actually output dance now, there's an Easter egg in .NET, so it will actually break dance?
What?
I'm kidding.
What? I was like, what? You got it.
Yes.
So let's
Perfect.
do it.
Yeah, let's do it. I should have just run with it and let you.
Did I take too long? I took too long. Oh, you gotta hurry now.
No, that's fine. We actually have one more thing to talk about.
Talking about endless loops.
Endless loops. Yeah, we can do that. We're going to talk about adding looping logic using do while and is it while do? No, it's not. It's while and do. So we can keep your list of people here. So it's Filip, Iris, and Luis. Maybe I'd like to ask for some input from the console and compare that to some of the names that I have in my list here. So we can write a little bit more complex code in this situation, so that you have something to play with. I want to write some code that always executes, and then after which I'm going to evaluate if an expression is true or false. So to do that, I can add a piece of code called do while. If I do this, it's going to say I'm going to run this code while this evaluates to true.
Yeah.
Now, if we simply have a true here, this is going to be interesting. It's never going to stop.
Actually, F5.
So I think that if we run this, it's not going to crash VS Code. It's only going to be outputting. I don't want to try this. So I could say that let's do a console.readLine. And this here is going to return a string. So I'll capture that. And now I'd like to compare if this is in fact empty or a new line. Would I then be able to use that here to say if this is string dot empty? Actually, there's a short string is null or white space. So we don't have to do that. Sorry, I'm going to be a little bit confusing. But I can't because this here lives in my do scope.
Yeah.
So, and I don't want to do it up here because that means it's only going to run it once. So how do I do this? Well, I can store a temporary variable called string, name is equal to string.empty. And then I can say, well, name is equal to whatever I read from the console.
Yep.
And then once I've done that, if this here is then true or false, it will either continue running the loop or not.
Will it always run the first time?
We can try. We can try that. So let's do something. Let's print this to the console as well. Hello, and we'll string interpolation. Hello.
You just pronounced it like it was butter, like string interpolation.
String interpolation. Well, yeah. All right, let's run this and see if this actually works. I'm going to run this, and you asked if this will always run. I'm going to see here if I can just get to my terminal. Let's get rid of this. Is it actually asking me for some input now?
I believe so.
Let's say Philip. Actually.
Oh, it printed. There we go. Oh, but it didn't say hello.
Well, exactly. So it didn't actually work.
Oh,
so I'll do it in the terminal instead. Press any key. Let's go into .NET Run. Or not. Actually, I have to write something because I'm not asking a question. So this will say hello, Philip. So it ran this once for some reason.
And .NET Run is the same thing as running.
Yes. So how come this only ran once? Because I made a mistake. Can you spot the mistake that I did here?
Wow.
Right?
Why
so
null or white space?
Right. So I'm saying we should only continue here as long as what I've entered is not non-existent. So let's do console.write. And let's say I want to write a string. Can I do a string here? I can write string. Yes. Your name, colon. So this is going to be a little bit more obvious. If I do this, run it again, it's going to say enter your name or your name. I'm going to click enter. It's going to say hello, and then it's going to ask me again. Yeah. So as long as I've not entered something, it's going to continue nagging like that kid we talked about earlier. Right? So when I write Philip, it's going to exit, basically. I could also negate this and say, well, as long as you don't enter something that's non-existent, I'm going to save this. I'm going to rerun the application. Sorry, I'm just going to clear this first. I'm going to rerun this. I'm running this from the console now because I'm not really fond of how VS Code works with the terminal. So I'm going to say, your name is Philip. And then we can say Iris. And if I don't enter anything, it's going to terminate the application. Yep.
But you always run at least once.
At least once, yep. Always. That's the benefit of doing the do-while loop.
Do-while. Do-while. And I have to say, like, please do not send emails in a do-while loop.
Right.
I might have or might not have worked at the company that did this.
Yeah.
Maybe. I don't know. You know me. I make things up.
Did you, though? That sounded like a very much real project.
I didn't write the code, though. I didn't write the code.
Right, right. It's always someone else.
I remember learning in school with do-while that it's not something you use very often, but when you do, make sure you plan the while. And plan it well.
Do plan the while.
Do plan the while.
Yeah. So this is a great
while you're at it.
Yeah, so many puns. All right, so this is a great thing to use if you always want to run this code snippet at least once.
Yeah.
If we were to take a slightly different approach, I'm going to comment this out, and I'm going to do something similar. Quite often, I see people do while true. Because it's fine. Like it's fine as long as you have, as long as you have in mind. Yeah, as long as you have a break. As long as you have a clear picture of what's going to happen here, like it's fine. I could now say that forever and ever, we're going to ask for your name. I'm going to read this from the console. I'm going to print the same thing as I did earlier. So again, this here takes the while, takes an expression which will evaluate to either true or false, which we can see by what this is doing here. So this could be looking at something else. That will evaluate every time we're going to execute this. Yeah. So if I were to use the same condition I did here at the bottom, this would be a little bit problematic because I've set this to empty. And now I'm saying, while the name is actually not empty, this is the input to my method is null or white space.
It's never going to go there.
It's never going to run this portion of the code. So therefore, I might end up doing a while true, and it's fine in some cases. But how about I then want to exit this when my condition is met? I could say that, well, if the name is now, if it is in fact null or white space, I want to do something. I could then say I want to break out of this loop.
Yep.
And this is a great place to do this in one line.
You can always take a break.
You can always take a break. Right, so now I've gone a slightly different approach. I'm using a while loop to iterate something. I'm not iterating a collection. I'm not iterating over anything. I could have iterated over all the names and said that while there are things left to iterate across, but that's not really what I'm doing here.
Yeah, so that's the difference. Like the other, like for and for each, you're iterating through a collection of sorts.
Yes.
But while and do while, you're looping. You're always looping.
Yeah.
And you don't need a collection to do that. When would you use while and when would you use do while?
To be honest,
do you have an example, like when you've used?
I have a very good example here. Right? Whenever you always want to run some portion of the code, I would do this. So, for example, I wouldn't use this if I first have to ensure that a condition is met, like the email example that you had. I wouldn't first send an email and then check if it should be sent or not. I would rather have that inside my loop here or something like that.
Actually, sending the email and then checking if the email was sent, but there was some lag for when the database got the new values. So by the time it exited, it sent like, I don't know, like 50 emails or something.
Stories around that as well.
Because loops are fast.
Loops are really fast, sure.
Yeah.
We can get back to that soon, actually. I have a good analogy here as well. I changed my code slightly to say that while we, actually I'm going to refactor this, should loop. While we should loop, this will be true the first time. And that's a quite common thing to do. Like we always have an expression that we've evaluated to true because we want to run the loop. The assumption is that we're going to run this code. We're going to run some code. And then if our condition is met, we might say that, well, I'm not going to continue, or I'm going to change some external variable.
So this has the same effect as doing a break, but readability is so much better.
Yeah, and this expression could be coming from somewhere else. Should I make this a little bit more advanced, just to show you exactly what I talk about? So let's say I have bool here, and we could have a method that evaluates. Right? Let's do this, and let's return false, for example. Now, if I do this, what do you think is going to happen? Actually, let's do true here. Creating methods is possibly outside of scope of this module, but it's still an interesting thing to talk about.
I mean, you could be calling a method on a string, for example.
String is null or white space or whatever, right? So this here could be calling whatever. So every time it evaluates if this expression is true or not, it's going to call this method.
Yep.
So every time the loop is supposed to run, it's first going to run this method here. So while this always returns true, we can do this as well, right? Or equal to a certain value or whatever.
Email sent.
Whoops. Sorry.
You're trying to.
that was not any product placement.
Oh no,
at
there
all.
we go. My courses again. Oh shoot.
That was not my intention. Sorry. I apologize. I'm going to get yelled at after this. Sorry. All right. So with that being said, this here will always execute this method call whenever it runs that, right? So I think we've kind of covered everything so far. We talked about ifs and elses, how expressions are evaluated.
Yep.
And this here will be executed every time. I know you might not have learned methods yet, but basically you've probably experimented with calling things like readline, is null or white space, and use other helpers like that. Yeah. And you've discovered how to use the scopes and taught me how to write more beautiful code.
And crashed
And you crushed my machine, did some product placement, talked about things that we probably shouldn't. No, but all joking aside, I hope everyone that's watching this have learned something and found it inspiring and fun. And then,
And if you liked it, let us know. And if you didn't,
don't let us know. No. Now, all joking aside, like we would probably love.
Should we do
some
a
good
shout
feedback.
out? Like, let's see if there are any
Yeah, let's see if there's
questions.
anyone
Can we
left.
get some questions? We have 10 minutes left.
Yeah,
and,
sure. So scroll down to the new comments. There's a lot of discussion in here.
Continue the discussion with our speakers.
Yeah.
Wait, what? We have to continue? Was it going to go
The
buy
stream
flowers?
is for another 5 hours.
Good time for coffee. Yes, I'm drinking coffee.
Yeah.
Oh, no, Duca. Oh, I was just thinking about sending emails using that. Didn't work out for us.
Oh, I do.
But you do you.
You do you. Be nice. So actually, I want to mention something. You said that loops are really fast, and they are, depending on the machine you run them on, like, of course. Especially if you build applications later on that are using MAUI or other technologies for mobile devices, be very careful with something like while true, because the code in here will execute super fast, like it will consume all your CPU that's available. So it's possibly a good idea to introduce some backing off, like I'm not going to say thread.sleep, but something similar, right? So you shouldn't run it too quickly.
Thank you, Lewis, for saying we're funny. Can I screenshot this and show this to my kids when they're old enough to read?
Yes.
Because they do not think I'm funny.
Someone is asking if Visual Studio Code is better than Visual Studio. Like, it depends on what you're building, right?
I actually really, really like Visual Studio.
Yeah, same here.
Because it has everything built in. It has so much. I do appreciate a good, clean editor where it feels like I'm just working from a terminal, but it really depends on what you're doing. I find Visual Studio better when I do profiling, performance profiling, memory profiling. It has all those tools built in. Well, with VS Code, maybe there are extensions for that. I don't know. I assume there's probably something.
And
but
but
that's the thing with Visual Studio. I know it's all there.
Yeah. And the same here. Like, I've been using, I started C# development 18 years ago, I believe, and I've been using Visual Studio since then, and it's hard to just jump on something else, even though there's many good alternatives out there, like VS Code for other platforms. Even if I code on this thing, which is my other machine to build MAUI apps.
Oh, was that the logo?
No.
With the
so even if
on?
I use this thing, I still use VS Code. And sometimes I jump into Parallels where I have Visual Studio installed. So it doesn't really matter which platform you're on. You can always experiment with C#.
Returning to the fruit bug, I'm reading from the chat. I remember some months ago, something similar happened to me when reviewing a pull request in my team. There was an if statement, which was something like this. And it shows an if statement.
Yeah, without the scope, right?
Yeah,
so
without the scope.
Always have scope. You can do the same. Can I show that with the loop here as well?
Yeah.
Like, you talked about this earlier with the for loop, but we can do the same thing here. We could basically have send email, and we could have something like this in a one-liner.
Yeah.
And this here would now run forever, which is not really a great thing.
Nope.
So don't do this. There's a lot of good discussions, and thank you so much for participating and watching this stream and coming with suggestions on how to write better code and liking our jokes, or mostly Iris's jokes. It's a lot more funny than I am.
I forgot to say I write books. I'm plugging myself here.
Yeah, that's fine.
Yeah, I write a comedic fiction about programming. So yeah. So I have to be funny.
Let's scroll down to the bottom again and see if there's any new questions.
New comments.
Let's see here. Yeah, VS Code for the win.
Yeah.
You're getting a lot of shout-out.
RM, thank you for the compliment. It makes me super happy, because I always go like, people have forgotten me. I'm getting old. I started sharing baby pictures on Twitter.
That's
yeah.
All right. This has been a lot of fun. Yeah.
Yeah, it was fun.
Yeah. We should thank Microsoft for organizing this. It's been a lot of fun sharing some knowledge around C# and how to get started on your journey to learn more about C# and .NET.
It was a pure coincidence that we are basically neighbors. I live half an hour from here.
Yeah. I'm super happy that you came over and we did this here. It's a lot more fun than being on camera. So
and Sweden is much bigger than half an hour. So
pretty much can get anywhere in about an hour. I'm just kidding. With an airplane. All right. Thank you, everyone, for tuning into this. It's been a
Thank
pleasure.
you.
See you next time.
Are we doing the awkward wave again?
Yeah, let's do the awkward wave.